equations. All right, some people in the science world think that this is a really hard concept. So we're going to try to make this as simple and easy to do. We're going to make it color-coded to start with, and then hopefully you can go faster. Most of the things that we do will be easy enough that some of you, if math is your friend, you can do this in your head. So let's look at the basics of a chemical reaction and the chemical equations. So we've got zinc and iodine here in this picture on the left. So zinc is this darker color and then iodine is this white powder. When you add them together, it's like if I poured the white iodine into the zinc, I get zinc oxide, which then structurally looks like this, but it lets out this really cool purple gas, and then there's a heat change, so that's why this little triangle's here. So our chemical reaction happens when bonds in the outermost parts of the electron shell, or the valence electrons, are either formed or broken. So a reaction can happen when the valence electrons link together and form a bond, or when they're broken apart and create new substances. Chemical reactions involve changes in matter. This can be either new materials with new properties. It can also be an energy change, and by that it usually means that it either gives off heat or it takes in heat, meaning that it makes it hot or it makes it cooler. The symbols that represent the elements, the formulas, the chemical reactions also describe compounds or chemical equations that are changing. And then these two words down here, they're not critical that you know them, but it would be good to file them away in your vocabulary bank. Endothermic means that it happens within the reaction, so it tends to absorb the heat. Exothermic reaction happens on the exterior or the outside of the reaction. So this is usually a release in heat. If you want to know more about this, I'll try to put a link in the description that'll help you discover what that all is. So the next one is the parts of the reaction. If you think about algebra or basic math, like higher level basic math, you have the reactants that add together, and then you have the product, which is what is the sum usually in a math problem. So in the carbon dioxide question up at the top right in the green, I have the reactants, which are usually shown to the left of the arrow. The product is usually what's made, and it's shown to the right of the arrow. The plus sign in between the carbon and the oxygen separate the different molecules that are happening on the same side of the reaction. The arrow is traditionally called the yield sign, and it's kind of like an equal in math. So our example is carbon plus realistically 2 oxygen molecules give us the new molecule of carbon dioxide. So the reactants, like we said in the previous slide, are to the left of the arrow traditionally, and these are the part that mix or react together. The product or the answer is to the right of the arrow, and it's what's made or produced. It's also called the outcome sometimes, and if you look at word problems for this kind of thing. So chemical equations. This is a law of chemistry. So just like we had laws in physics, they are tried and true, they're proven. There is the law of conservation of mass or matter, depending on what you're looking at or studying, but they're the same thing. This states that the equation must be balanced and that matter cannot be created or destroyed, only cycled into new materials. So if you have the same number of atoms on both sides of your equation, then you have managed to prove the conservation of mass or matter within your equation. And this link to Lavoisier, he's a Frenchman. I'm going to put the link in that description about who he is, because I reference him a couple of times within our chemistry unit, and then again when we go through space, when we start talking about space, because his proof of this law is critical in both chemistry and then again when we do space later. So make this smaller because it's super big and we can't read anything. So the conservation of matter, the reactions cannot be created or destroyed. The reactions means that I have the same number or amount of atoms in the reactants and the products and that my number of atoms before and after the yield must be the same. So we're going to bring this back and make it bigger. Ooh, that's crazy. That's a little better. So on the left-hand side, or the product side, I have 2 hydrogen molecules. That's the 2 double H's here. The 2 hydrogen molecules, they're going to bond, usually with a little bit of heat and pressure, with these 2 oxygen molecules to then give me 2 water molecules. So if I count 1, 2, 3, 4 hydrogens prior to the yield sign or before the yield sign, and then I come over to after the reaction has happened, and I have 4 hydrogens. Again, 1, 2, 3, 4, the little Mickey Mouse. And then I have 2 oxygens and 2 oxygens. So this is a very simple, if this helps you drawing them out, then I would draw them out. Most of the time you can do them in our grid method that we're about to do. So some symbols and equations that you may see, most of the ones that we do in 8th grade, we might see this temperature change, which is just the triangle. That means it either got colder or hotter, but it had a temperature change. This is really the only one we will see at the 8th grade level. However, just so if you see them in a textbook or on a website as we do research, that you're not confused, the solids are usually indicated with a little S, the liquids with an L, the gas with a G. If it's in a solution, which means it's usually suspended in water, it has this AQ for aqueous. And then if there's bubbles that happen or gas release, then it usually has this little arrow up. So let's look at how we balance equations. You can add coefficients in the front of any compound or any molecule. You cannot change the subscripts. This is determined by the valence electrons. So this tells me how many of these little atoms I have. The subscripts are more atomic structure, where the coefficients are more how many molecules or how many compounds do I have. So you may need to write this in your notebook. Translation, you need to put this in your notebook. The coefficients are the big numbers. That's just they're coefficients. Subscripts, if you can remember subways, or if you remember from 6th grade with subduction, the subscripts are the smaller ones. This tells me my number of atoms within the compound, and the coefficients tells me the number of molecules in the compound. So it's a little different. It may help when we do this with manipulatives and you can see it with hands-on, but coefficients cannot be changed. Coefficients, can be changed. Yes, I can change coefficients. I cannot change subscripts. So we're going to skip that slide. So this page you should have gotten in your notes, and we will have filled it out together. This would be just a review as we're in class. I'm not going to go over it in the notes because you can go back and fill it in based on the 2 slides back. So balancing equations, I'm going to put this link here. This is, I believe, a Brain Pop link. So taking something hard and making it easy. The balancing of equations, or the fancy word of that is stoichiometry. We are going to do this in step by step and slow it down and try to make it simple. So step 1, we're going to draw boxes around each of our chemical molecules. And all of our plus signs, our minus signs, our yield signs, those are all indicating where I'm going to draw my box. So this is my initial chemical equation at the top. I have sodium hydroxide plus hydrogen sulfide, giving me sodium sulfate and water. So I'm going to draw my boxes around each one. So hopefully you're doing this with me. And then the second one is I'm going to make an element inventory. And all this is a list of each of the elements I have. And then I'm going to count them before and after the yield sign. So with sodium, if I come up here, because there's no number listed, I'm going to know that it's an understood subscript of 1. So in this box, I would write a 1. Same thing with oxygen. If you look up, it has a subscript of an understood 1, so there would be a 1. Hydrogen, 1. Except for I have another hydrogen group over here, so I may have to put 1 and then plus and then a 2. So that would give me 3 total. Sulfur, I have 1. And then oxygen, I have 4. So back up here at the top where I had my 1, I'm going to put plus 4. So that would give me 5 oxygens. And then you would come in and fill. See if I can actually draw these. Whee, I can. So sodium, I have 1. Don't make fun of my numbers. I had 1 plus 4 1 plus 2 and 1. So then after I come to look at after the reactant arrow or the yield sign, so with sodium I have 2, sulfur, make sure you line up which one you're working with. I have 1, oxygen, there is 4, then I have the addition sign, so hydrogen, I have 2, and then oxygen, I have 1. Just as a note, this subscript here with the 2 only goes with the 1 to the left of it, so it will only affect this hydrogen. It does not affect this oxygen. So then I've got that filled out, so now I'm going to go to the next slide. And it should kind of look like this. Let me go back and get my arrow because it's easier with an arrow. So with sodium, now I check to see if there's one that's not the same. So because the sodium has 1 and 2, these are not the same. So this is unbalanced. Oh, it's hard to write on this. So that's really all you have to do. Once you find one that doesn't match, then you just write unbalanced or UB and you're finished. If they all match, like if this was 1 to 1, 5 to 5, 3 to 3, 1 to 1, then it would be balanced because all the numbers are the same. But because this one isn't, it is unbalanced. This is another page if you did it with us in class where we just write, we did this as a group in class, so you have 6 carbons because this number does. So if I were to write in, I have carbon and oxygen and hydrogen. Oh, it's horrible. So then I count, I have 6 carbon for the oxygen. 6 times 2 gives me 12. And then I come over here in hydrogen. 6 times 2 gives me 12. And then 6 times 1, because I have understood 1. So then I add that to that. So then I come over here, and carbon I have 6. Hydrogen I have 12. Oxygen I have, ooh, see, that's why we have to look. Come back down here to hydrogen, 12. There we go. And then oxygen now, I have 6, and then plus my 12. So then I'm going to come over and get another color pen so we can see this a little better. So 6 and 6, those are the same. 12 plus 16 is 18. 6 plus 12 is 18, so those are the same. And then 12 and 12, those are the same. So this one is balanced. And so then I'm done with that one. These you'll be doing as a group on your table, so we're going to skip those because those are done with your group. If you want extra practice and some extra homework, if you draw these out and give them to me by Friday, then we can apply that towards your test grade. And then here's another one that we did as a group. These 3 or these 2 we've done as a class, and they're left up around the room, so I'm not going to do them on this slide. So if you have any questions, please go back, reflect, and I'll email me if you have any questions. So that's it. I'll see you in the class. Let me go back so I can get my select so I can stop. Have a good one.